He said he'll join eventually.
Yeah. Oh, he'll join later? Okay. Okay. Very nice to meet you guys. So thanks for the nice introduction. I'm very glad to be part of this talk, like be back in my alma mater. So I prepared some, slides for you guys. I'll try to share some of the experiences that I have had in my industry job. So feel free to interrupt me like as I'm kind of moving forward in the presentation. I don't want to be like have this like as a one-sided presentation. I'm open to have like any discussions, any questions, and I'm happy to learn basically from you guys as well. So okay, so let me share my screen. Can you see my screen?
Yes, we can see your screen.
Perfect. Okay, so my name is Amin. So I'm currently a data science manager at Walmart. So I joined Walmart like 4 years ago as a data scientist, senior data scientist. So before that, I was a PhD student at Mississippi State University. I did my PhD under Dr. Maruf's supervision. So during that time, I had the opportunity of working on different kind of cool supply chain problems from location routing, fixed charge network flow models, developing like different decomposition algorithms for MIP models like stochastic programming models. But meanwhile, we had the opportunity of working on some machine learning, reinforcement learning models as well. So I really cherish the time that I had in my PhD. I think I'm always like grateful for Dr. Maruf's like endless supports during that time and even after the PhD. And also, I wanted to express my, gratitude to Amir for arranging this call and also the Informed Student chapter at Mississippi State. I'm humbled and also honored to be part of this talk. So, with that, so in this presentation that I have kind of prepared, I'm going to have like three main sections. First, I want to talk about some of the two of the problems, supply chain problems that I have been kind of involved in order to solve in my current role. Then I'm going to talk about like some tools and skills that I feel like they are kind of in nowadays, like, industry jobs are kind of important in order to be kind of, efficient and be able to use it in your day-to-day job. And finally, I have some, some interview tips if they may help you guys like in order to land in a job which is kind of a good fit for based on your skills. So as I said, so I, when I my current role is kind of related to kind of supply chain strategy at Walmart. So there is a dedicated team of data scientists, strategists at Walmart who work like hand to hand in order to solve like different type of problems for the end-to-end, e-commerce supply chain at Walmart. So any e-commerce supply chain can be kind of classified to three different legs. So the first leg is called the first mile. So you basically have like a set of suppliers. They could be domestic or kind of import suppliers. Then you need to basically bring all those volume to your inbound cross-dock facilities. So there you are going to kind of do some inspection, do kind of brick container process, and then you are going to cross-dock those volumes to some of the consolidation centers. So in the consolidation centers, then you need to do some, break pack, again, inspections. And once you have the units, then you are going to use basically those volume in order to replenish the fulfillment centers down the road. So this leg of the supply chain is called the first mile. The next one is called the middle mile. So once you have the inventory in your basically fulfillment centers, Then there are multiple paths in order to go from those fulfillment centers to your customer facing node. So you could use like, third-party carriers. You can use like Walmart paths in order to do that. And say you basically do the middle mile distribution and you have the volume in your last mile leg. So then basically that last leg, which is kind of, where you are kind of uh, facing your customer, you need to fulfill the delivery is called the last mile delivery. So in this presentation, I have two simple kind of problems from middle mile and also last mile, where we are using kind of operation research plus like machine learning in order to solve those problems. So the first one that I want to talk about is the last mile transformation, where we are trying to design a network of the parcel stations. So currently in Walmart, when customers place like order, majority of that volume goes through the third-party hubs. So you have the FedEx, LaserShip, USPS, and basically you rely heavily on those 3P carriers in order to deliver your packages to the customer. And that's not a pleasant experience for Walmart, because that introduces lots of, lots of inaccuracy and lots of, inefficiency in delivery of the packages to the customers. So in the future state, what we want to do is, so we want to open or launch a network of parcel stations that are co-located with your basically Walmart store, where you can basically use Walmart line haul trucks in order to bring that volume to the co-located parcel station. And then you have the van, basically Walmart-owned vans or gig sedans in order to deliver that packages to the customer. The reason for this is that basically currently in each of the Walmart stores, you can possibly have like 60,000 different SKUs. But in order to have like a, good competitive benefits compared to our basically, competitors like Amazon, we are trying to, increase the number of assortments, the SKUs that we want to deliver to the customer in a good speed. So that's why this is the FC fulfilled kind of, packages are very important. So FCs are typically much larger than parcel stations. So instead of having like 60,000 SKUs, you can have like 2 million SKUs in each FCs. And every day, based on the customer demand, you can kind of aggregate that demand through Walmart, basically line haul trucks, go to the parcel station and basically own the entire process of the doing the last mile leg, basically. So doing this has some benefits. So it's kind of helping us to consolidate our volume with part of the kind of the last mile deliveries that are sourcing from store itself. So you have the grocery deliveries, you have the some ambient deliveries from stores itself. So once you have this FC source volume in your store, you can kind of densify those trips and bring down the cost, overall cost for your last mile leg. So this is a very important project for Walmart. So they wanna basically come up with a network, a transformational roadmap in order to see that basically based on the demand forecast that we have for the next 5 years. So where and how big of the parcel stations we should need basically launch in our network. So here I'm kind of talking about the challenges that we had in order to solve this problem. So the first challenge is that, so in this model, you need to kind of, model different types of flow paths. The first one is kind of, you can directly go from your fulfillment center to the parcel station. The next flow path is you can go to some sortation centers. Basically, you can connect some uh, fulfillment centers to one sort center, consolidate volume there, and then go to basically your parcel stations. And then you can even use your Walmart fulfillment centers as your parcel station and do the delivery. So for each of these flow paths, you have different CapEx requirement. different kind of, processing costs and different business requirements. And the next thing is that, so the volume that we are going to fulfill from our fulfillment centers can be classified in sortable and non-sortable based on the size and the weight they have. And for each of these category of the volumes, you have a different kind of, requirements in terms of the vehicle mix. So if your kind of items, the deliveries are smaller, you can use van or sedan. But if you are doing like large scale, like sofa, like, I don't know, television, then you need to use like box trucks, larger vehicles in order to basically do the deliveries. But the thing is, if you kind of, co-locate these parcel stations for different channels, sometimes you can consolidate the volume across different channels and have better last mile costs. So here you can see the trend that we are kind of, we are forecasting for Walmart FC source kind of deliveries. And based on our forecast, we are kind of, forecasting that the demand will grow by 3 times in the next 5 years. So you need to be prepared for that demand and have a very optimal network where you can kind of, meet the customer demand. So the next challenge that we have for this problem is that, so this is a combination of 3 NPR problems. So you have some candidates, which are your current Walmart stores. You want to just cherry pick for some of those basically Walmart stores as your parcel stations. Then you want to basically design a service area for each of those selected locations. And when you want to design that basically catchment area and select those nodes, part of the decision is related to the vehicle routing. So the, the vehicle routing cost is very important in order to see how big that basically catchment size should be and how many nodes in each market we should pick. So as you can see, this is a very hard problem when you want to solve it like in a Walmart scale. So what we kind of do. So before I talk about the solution that we kind of came up in order to solve this large scale problem. So I just want to little bit talk about the way we plan to solve the models. So first thing is we spend lots of time in order to see what are the inputs, what are the data models that are going to be fed to the model. So that way we are going to have like a very consistent like pipeline in order to the data collection. And also we are kind of collaborating with our business partners and they tell us the business requirements. And based on that, we can kind of fine tune the model that we want to basically develop for our basically partners. And also one other important thing is that I think before developing the model itself, so you need to know what are the inputs, the data models that you want to use, and also what's the output. So for instance, for in this specific one, we want to run the whole network for the 5 years like continuously, and then uh, you want to, for instance, estimate the delivery cost. You want to know what's the vehicle mix in each of the nodes, how much, capital expenditure you are going to have like for each of the years and etc. So once you have all those information, like for your inputs and outputs, then you know that, okay, for this mathematical model, so this could be a good kind of objective function. This could be a good kind of, constraints. And then you can kind of uh, see if the commercial solvers can solve it, but most of the time, since the scale of the data is very high, it's not going to be solved. So you need to come up with some novel kind of, ways in order to solve it. So the objective function in this problem has like several parts. So like the capex, the middle mile cost. So if you want to outsource your basically part of your volume to your 3P network rather than parcel station cost, you have the 3P cost. And the important part is the last mile delivery cost. So if you want to do a point-to-point routing and solve this whole problem, considering by introducing those basically vehicle routing related decision variables, we all know that it's not going to be tractable. So there should be a way in order to uh, simplify this part of the model and basically solve this model in a tractable, basically time manner. So one thing that we noticed is, so there is this basically Uber H3 pixels, which is kind of a geospatial indexing system. And using that, you can kind of partition the world to this, uh, varying size hexagons. So the good thing with this basically framework is that, so based on your basically problem, you can select the resolution of the pixels. So for instance, here in this pixel that in these pixels that I'm showing here, so these are resolution 7 pixels. For resolution 7 pixels, the area size is 2.2 square mile. And then based on the the deliveries that you have, you can easily map those lat longs to those basically pixels. And once you have that basically mapping between lat longs to the these unique pixel IDs, then you can aggregate the demand in pixel level instead of dealing with each of these dots as your basically units in your last mile delivery. You can deal with these pixels. So what this means is, so if you have a solution in order to estimate the cost based on the density of those dots inside these pixels, rather than doing that point-to-point basically delivery, then the complexity of your model will not be driven by the number of nodes, exact nodes that you have. It's going to be driven by the number of the pixels that you have. So what we did here, so we did some literature review and we saw that there is a nice MIT research paper, which is using like this density based on an area kind of in order to estimate the last mile delivery cost. So here you can see this formula. So they are saying that if you assume you have this basically K, this is your basically delivery area. And in this delivery area, you know how many, what's the area size, what's your demand, how many deliveries you have. So using this formula, you can calculate what's the inter-customer distance. So what is inter-customer distance? Okay, so you have this, say this is your store, this square dashed square that you see is your basically delivery area. So the first leg between your store to the first basically customer is called the stem distance. And you have basically return stem distance as well. But once you reach to the first customer, then you are going to visit the next, customers one by one. So the distance between those two consecutive customers is called the inter-customer distance. So what this paper is saying is basically, if you have a way to calculate this inter-customer distance between two consecutive deliveries in a specific area, then you can estimate your routing cost with a good accuracy. And the way they are doing that is like this. So first, they calculate the density using this formula. They calculate the inter-customer distance. Once you have the inter-customer distance, you have the doorstep time. You know basically what's going to be the shift for each of the vehicles that are going to be used for your delivery. What's the loading processing time? What's the stamp time? Then you can calculate basically how many deliveries you can possibly have in one shift. And then based on the cube size for your deliveries, what's the maximum capacity for your basically vehicle. And you have this D shift, you have the max capacity, then you can get the minimum of those two in order to get the number of the deliveries in one trip for that area basically. And then once you have the number of deliveries in trip, the whole demand in that area, and then you can calculate the number of trips that you need to do basically to fulfill all the deliveries. And once you have that basically number of trips, then you can kind of calculate the last mile cost based on this all these equations. So one thing which we noticed was, so using this basically formula, assuming that this K is consistent across the US is not a good idea. So we did this test, like we used actual VRP solvers and we used this formula and we did some comparison in different markets, and we saw that the gap between two solutions can be varying like between like 20% to 5%. So that means that we cannot just use one simple kind of, consistent key for entire network across the US. So what we, in order to basically fix this problem, what we did was, so for each of the markets that we have across the US and each of the candidate locations that we have, we did some sampling. So we grew the pixels using that basically Uber H3 framework that I mentioned. So we assume like we have like 10 demands here, we have 20 demands here, 50 demands here. So we change the catchment size, we change the number of demands in that. So you can kind of play with the, the density in that way. So, and for each of these basically iterations, we use the TSP solver in order to see what is the optimal way in order to traverse across these nodes in this basically catchment. So once you have this basically uh, optimal TSP path, then you have a big data set. So basically, based on different catchment size, based on different densities, you know what's your basically actual inter-customer distance in different markets. Then you can basically train a simple linear regression in order to find out, okay, what is the correct kind of weight for that inverse of, square root of the density in different markets. So that way, kind of we uh, came up with a way, and in order to basically better estimate the last mile delivery cost using this basically methodology, which was already in the literature. So so this is how the formulation looks like at the end. So instead of having like, explicit VRP decision variables, so we have just some assignment variables. So we are saying, okay, each of the pixels should be kind of assigned to which location. And we have some, business requirements related to the catchment, some business requirements regarding the middle mile, and also some specific channels. And then this framework, this mathematical model is very kind of, tractable to solve because you don't have those decision variables for the VRP. And once we have that, then basically we can kind of solve this problem for different scenarios. So for instance, here, I'm just having this, figures which are for illustrative purposes. These are not like exact numbers. So here you can see that for like small and medium demand channels, it's coming up with this kind of, 22 locations. For large and extra large, it's coming up with this 3 locations. And the good thing with this framework is that since you are kind of simplifying your model, although you are kind of keeping the accuracy, your results are very reproducible, meaning that you can solve it in this computer, your friend can solve it another computer for such a large problem. And you can get exactly same solution. And that's very important because your credibility is important. You cannot just solve, the same input, same model, and get the 2 different solutions. Meaning that if you want to get a very reproducible solution, you need to solve it like with a very minimal gap, like less than 1% or so. So with this, I think everybody is happy. So you can reproduce like good solutions. Your solutions are accurate, and also you are solving like different scenarios, like in 2 hours, like for entire US, which is a very good number in Walmart scale. So basically, so this is one of the problems that we solve kind of for last mile piece of the supply chain. Now, I would like to a little bit go to the upper stream, to the middle mile. So what happens from fulfillment centers to that basically customer facing parcel stations? So there is a concept in supply chain which we call it sales velocity. So basically, based on the number of the sales that you have per week, you can kind of classify your different SKUs to head, super head, torso, tail, and super tail. So if an item is like a head, super head item, it means that it's selling very high, basically every week you're selling maybe, I don't know, thousands of that item. So if you want to, in this competitive environment of the e-commerce supply chain, if you want to be very competitive, you need to have all these items in all different fulfillment centers in network. You want to be very close to customer. So every time customer wants to order that basically item, okay, you say, I'm going to deliver that in 1 day. And customers will feel good. Okay, if I've ordered this from somewhere else, it's going to take like 3 days. Walmart has it, like, let's order it from Walmart in 1 day. So this, we call it mirroring strategy. So based on that mirroring strategy, which comes from a different model, first, we decide, okay, in each of these fulfillment centers, what subset of SKUs will be kind of stored basically for our fulfillment. And then basically you have these zip codes. And the problem is basically for any uh, order that the customer is placing, you want to know that, okay, what fulfillment center I should use. And once you decide which fulfillment center should be utilized for that, you want to see what's the optimal flow path. Should you go through the 3P? Should you go through the 1P, like Walmart on fleet? Or should you go through the, the stations, the 3P hubs, and etc. So this, I hear myself. My voice is echoing. Is it?
You're audible.
You can hear me?
Yep, you're audible.
Okay, perfect. So yeah, so the problem that you want to solve here is basically which FC, what flow path you want to use in order to fulfill your demand in this specific zip code. And again, when you want to solve this problem, because of all those business requirements, the Walmart scale, this becomes a very challenging problem. So you need to split the problem in two, parts. In the first part, we are solving the demand assignment, meaning that we decide which FC for each zip code and each, SKU type should be selected using this mathematical formulation that you have here. And then once we fix the origin, destination, commodity type, we have this basically second step, which we call it like the cost optimizer. So in order to solve this basically flow path, you have like two variants of the network flow models. You can have like node arc formulation, you can have like arc path formulation. One important thing that business asked us to basically consider in our formulation was, so for a specific origin to destination, you don't want to split your orders. You always want to go through just one path. You cannot go to two different sort centers and then go to one basically zip code. You always want to go just through one sort center to one basically zip code. And that basically implies that you cannot use no dark formulation. Otherwise, you need to introduce like millions of binaries for each of those legs, which will help you to kind of, retain the one path constraint for each of those basically commodities. So with that, we decided to use the arc path formulation. So here you can see that, okay, so this is your origin, this basically yellow squares that you see, and this is your basically destination. In order to get from this location to this basically zip codes, you have all these different basically flow paths. So you can basically directly go to Walmart delivery station and then deliver to the customer. You can outsource all the process from your FC to your third-party carriers. So you can ask the FedEx, LaserShip, USPS to come to your fulfillment center. You are going to load those trucks and they're going to just promise to deliver that package in 2-3 days. So we call that parcel path. And then you have some other paths where you can use again your uh, 1P paths, like you can go through your sort centers in order to consolidate the volume and then go to delivery station. And also you can sometimes, there are some, SKUs for which we are kind of, our mirroring strategy is not doing good. So in order to fulfill a package in New York, we are fulfilling it from LA. So we cannot deliver that in 2 days. So you have to go through the air paths. So by basically giving this visual, I wanted to basically tell you guys that for this problem, so you have, if once you want to solve the problem, you are enumerating like 10 millions of paths, like in every basically scenario. And when we kind of fit this to a commercial solver like Groovy, it takes like, I don't know, 7-8 hours to just solve this step of the problem, this basically cost optimizer. So one thing that we noticed is that, so not all of these basically enumerated paths for the same origin destination are efficient. So why we are fitting those to our basically mathematical model? So there could be some ways using which you can identify the inefficient paths, eliminate those paths, and then solve with a reduced basically size of problem. And basically it can make your problem more tractable and solve it in shorter time, hoping that it's not gonna increase your cost basically. So in order to solve this problem, what we did was we came up with the XGBoost classifier. So the way we handle this basically, so we come up with some feature engineering for each of these basically, paths. We calculate, for instance, these are some of the features that we are using in our models. Like what is the deter ratio if you want to, instead of using the direct paths, if you go through the sort center paths, like the 3P paths, etc. What's the extra miles? What's the degree of diversion if you want to use the other paths? What's the gravity score? So for instance, if two cities are very big, they have like a small distance, then the gravity between these two cities are going to be higher. So you need to do basically some feature engineering in order to basically make these different paths distinguishable by, your ML classifier. But the important part is the labeling coder. So basically you want to label your potential paths as efficient and inefficient. So based on the previous, historical runs that we got from optimization, we checked all these basically features that we developed for each of these paths. And we saw that, okay, for instance, for optimal paths, we see that the detour ratio is always less than 1.3. The extra miles is always less than 150. The degree of divergence should be less than 45 degrees. So using that basically information that we have from previously solved solutions through only optimization and some business basically rules, we label our paths and then we train basically a XGBoost classifier, which gives us basically a prediction model which can be used like, on the fly when we are running the optimization model, when we have the inputs, when we enumerate the paths, then you can basically use this classifier and label all those basically paths with inefficient and efficient. And all the inefficient paths will be kind of removed from your optimization. And then your basically runtime, based on our experience, is kind of, we see that 40% of the runtime is reduced. So instead of spending like 6-7 hours, we are spending 3 times. And that's a kind of a big improvement to make this model more pleasant for our basically business partners. So here, this is just the mathematical model that we use for solving that model. I think the reason I put it here, I just wanted to show you guys. So these are the binary path variables, which kind of using the path pruner that I explained in the previous one, we are kind of reducing the size for this specific binary path selection variable. And once you have like less numbers variables here, so you are able to basically solve the model faster. But the important thing is that you don't want to basically increase your cost by eliminating some of the paths that could be potentially good one for your basically next scenario runs. And for that, you need to basically always have a good quality, training data set using which you can do a good job in prediction as well. So one thing that I want to mention about this project is that, so once we kind of did this development, we made the model very efficient to be solved like for different sensitivity analysis. And we saw that if we include even more business constraints, different type of objective function, the model is able to handle kind of, large scale kind of, requests from our partners. So this kind of helped us to kind of, make connections to in our operation teams, transportation teams, and they asked us to solve basically this mod to run this model rather than for future for the historical. So basically they wanted to see that, okay, like 3 months ago, we used these specific lanes between Walmart to the 3P carriers, to the Walmart owned facilities. So where we were doing like a bad decision. So based on this model, we kind of found out that there are like, I don't know, 40, 50 new lanes using which you can connect the fulfillment centers to the 3P carriers. And that can kind of introduce the, without launching any new node in the network, you can increase your 1 day and 2 day delivery speed by 10 and 15%. And that's in business, that means a lot. I mean, one of the key metrics that they are kind of usually kind of, tracking for any supply chain metric is speed. So they want to see that, okay, for how many of customers we are going to deliver our packages in 1 day. Okay, it is 30%. It's low. We need to increase it to 40%. And the reason for that, if you improve your basically your CVP to the customer value proposition, then you are going to be kind of more pleasant to the customer to come back to your basically application later on. So that's one of the kind of, leverages that Walmart has chosen in order to basically to compete with the other companies in the same area, basically. So yeah, I think this is kind of the problems that I wanted to talk about that we kind of solved in the last 3-4 years. So these were kind of the places where we use kind of both optimization and machine learning together in order to solve that. And I thought maybe that could be a good, exciting thing for you guys to see. Okay, although we are operation research data scientists, we don't have to always like you work with the mixed integer programming, work with like commercial solvers. There are places where you can kind of leverage machine learning, not just for your input, for demand forecast, even for your kind of solution approach, in order to make your basically solution better and more tractable. So with that, I would like to talk a little bit about some of the tools that I feel like we as a graduate students, we neglect. Actually, we don't go after these tools because I think in our day-to-day life in graduate, period, we don't need to use these tools that much. But I think most of us end up having a job in industry. So I feel like if you want to have a smooth kind of, experience in finding the job, onboarding the job, these tools are very important. This can really help you to have a better experience in these two areas. So basically, so the first one that I want to talk about is the database. So in graduate studies, we are not dealing with much of databases. We mostly use like SQL, Excel, CSV, those files. But I think there are some tools like the PostgreSQL, SQLite, DBware, so you can easily build like local databases in your local machine and use these tools in order to see, okay, how I should basically query from that local database instead of reading my data from CSV and Excel. This is going to be very close to how you are going to read your data from basically databases in the industry job as well. There are some new kind of, formats for reading data formats and also the data manipulation, frameworks. One is the Parquet, one is the Polar. So Polar is kind of a improved version of the Pandas. So it's kind of doing the lazy evaluation, meaning that instead of like handling the whole table, it's kind of looking at only those columns that you need for that specific filter operation process, like for your data manipulation. And it also kind of, it is automatically kind of multi-threaded. It's doing the parallelism when you kind of deal with the large scale data sets. And when you Parquet is just a specific kind of data format. And when you merge these two, you can see a huge benefit when you kind of, work with large scale data sets. The next one that I want to talk about is the Pyomo. So um, in big companies, like you have access to different commercial solvers like Cplex, Groovy. But the thing is, if you develop your model using the Groovy syntax, and if you want to see that, okay, how Cplex is doing, how good or bad is doing compared to Groovy, then you need to again develop the code for Cplex and then basically do the comparison. But Pyomo is basically a general framework for mathematical model formulation. So you can define your formulation and you can connect any solvers to that Pyomo. So you can use basically Groovy, you can use the uh, Cplex and everything that you want. So that makes changing the solvers part very easy. The next one is the basically the GitHub and Docker. So I, even I feel like in academic, like research areas, we don't need much collaboration. We work like in isolated silos, so we don't feel like we need to use GitHub that much. But as you start your work in kind of industry, you'll see that how important GitHub is basically in order to the version control. So if I were you, I would kind of for even for your academic projects, use GitHub, and if they're kind of if it is okay to make it public, make them like a public repository, and try to kind of follow the industry standards. Like you have the main development feature, branches, and then try to basically do the commit, merge those things in order to practice like how to use GitHub before you start your basically industry job. And Docker is like very important when you have like some application developed and you want to basically not only pass the code, you want to pass the environment, you want to pass all the dependencies. And this is a very good, cool, basically, tool, which is kind of solving the problem of kind of, it works on my laptop, but not on others. Why? So this is very helpful. And the next one is the Streamlit and Django. So these two are mainly for creating like interactive dashboards. So developing the framework is just one part of the story, but how you kind of, present that you to your leadership or other teams is another story. So using especially the Streamlit is very efficient because it doesn't have basically the backend part of the the dashboard development, application development. It is just the front end, and you don't need to know about the Java, HTML, CSS. You just need to know Python. Using the Python syntax, you can create like very good interactive dashboards where you can have like all the features. You can import all the scenarios, etc. Django is a little bit more sophisticated, so think even myself, I'm not good in this area, but just put here to, if you guys have more time, you can go through this one as well. So, but I think the most important one here is the GitHub Copilot. I think in this era where AI is kind of evolving very fast, I think it's very important to know that what would be the best strategy in order to leverage AI in our day-to-day life. So in companies like Walmart and all other companies, they are like, localized AI kind of assistants. Like in Walmart, we have YB, we have Code Puppy. So they are kind of, they have contracts with those kind of AI companies in order to not breach the data. And they're kind of trying to uh, provide some instructions when you create dashboard, when you code, when you work with some specific, data sets. So they already have some instruction in order to how to interact with those things. But you can build that basically localized AI assistant that Walmart has on your local machine. You can use GitHub Copilot. And if you kind of search this framework in kind of, internet, you'll see that you can easily create like, oops, you can easily, build some Copilot instructions. You can build some prompts. You can build some agents and also skills. So using instructions, you can basically say, okay, whenever you wanna build a map for me, so use this type of colors, use this type of basically tools, use basically, for instance, volume or plotly. So you give like instructions in order to avoid like, back and forth iterations between you and AI. So it knows that, okay, if I'm working for this guy, he needs this from me. So I'm gonna like focus on this in order to develop this code. And similarly, you can make agents. So basically you can make a, and by the way, all these are like markdown files. You are just writing the text and the Copilot itself is just using all these markdowns in is basically context window in order to basically respond to your thing, your request. So this is a very cool thing. So try this if you have time. So just wanted to show this to you guys as well. Then I have just quickly about the interview tips. I'm gonna finish this like in 1 or 2 minutes to give back some time for you guys if you have any questions for me. So first thing is the DSA and data structure algorithm and the SQL. We industrial engineering students, we don't pass in any course related to the data structure and algorithm. If you are a PhD student, take a data structure algorithm course from computer science, very useful. Try to realize, have a very good idea about all these basically concepts. Although we have the AI assistant, I don't think like they're gonna kind of let you use like AI in the interviews. You need to know how to do the binary search, two pointers, sliding window, how to traverse different trees, and etc. When it comes to SQL, these two skills are very important. How to use the CTs, like the common table expressions, to kind of connect different tables and queries to each other, and also the window functions. So these two are very important. So keep in mind to practice for this. And then for operation research related areas, so here I didn't kind of capture all the required kind of concepts. So these are some of the concepts that you may slip your mind and you feel like, okay, these are very simple things, but kind of majority of the interviews that I have been kind of the interviewer or interviewee, uh, these are the type of problems that they're kind of asking the question. So you need to know what's the knapsack, what's the bean packing problem, what's the heuristic, like, in order to solve that, because in industry, it, it's not about the developing like cutting edge solutions like which you can kind of publish in very good journals. You need to know what are the heuristics and how you can make them better to solve for basically your models. Then you have to know some information about these basically algorithms like vendors, column generation. In some fancy companies, they ask some Lagrangian relaxations. So then you have the machine learning part. So be careful with the missing data, how you want to fill those missing data. Because in industry, most of the time, this is the 80% of the time that you are going to basically spend when you work with any machine learning type of kind of projects. You need to fill in missing data. You need to know how to deal with different categorical variables and also the imbalanced data set. One important thing is basically the feature engineering. In my opinion, it's very good to work with some projects in Kaggle and also the some of those basically repositories in the GitHub to see that, okay, people specialize in a specific domain, how they are kind of doing the feature engineering using the existing data, how they are coming up with new features. That's very important and helpful. So in some of the ML related interviews, you will see that they're going to give you some data set and they're going to ask you to come up with new features. And if you don't have like, preliminary information about it, you'll be in trouble. So, and if the position is related to the deployment, like the operational kind of position, then you need to know about the the deployment and monitoring. So yeah, I think this is all about the interview tips, tools, and also the problems that we are kind of dealing with in Walmart. So try to wrap up the presentation in the 40 minutes. Thanks for listening, guys. Don't know.
Thank you very much for this insightful presentation, Dr. Lowry. I really enjoyed that a lot. So,
Thank you.
what I'd like to ask is, from your experience, how different is solving problems in industry compared to academia? I mean, what do you think mainly distinguishes academic researchers from industrial researchers?
Very good question. Academic researcher and yeah, I feel like one of the main things that I see is different, like in academia and the industry, is the data. The way we kind of manipulate data, deal with data is very different, like in academia compared to the industry. I feel like that's because of the, the security of the data and maybe, I don't know, the scale of the data in the industry is different. So you need to be equipped with like some, skill sets in order to do data manipulation, the querying data more efficiently in, uh, you know, um, in industry compared to the academy, in my opinion.
Oh, I
So
see. So the
yeah,
main is on data somehow.
yeah, I think data is very, how to deal with data is very important and different in
But
industry and academy. Yeah.
So yeah, one question I had was, and we commonly ask this to our speakers, is looking back at your PhD journey, what skills or experiences turned out to be the most valuable in your current position?
Very good question. Thanks for asking. So yeah, I feel like, yeah, being a PhD student is a great opportunity because I think they are giving you the problem and they are not telling you how to solve it. So you have to basically navigate yourself through all those ambiguities, and that's very helpful. So as a PhD student who is kind of preparing for industry, this is what you are gonna do like in your basically industry job as well. So they're gonna give you some even more ambiguous problems, and they're gonna ask very, very, you know, uh, hard deadlines in order to deliver that. So how to, in my opinion, how to deal with ambiguous environment situation and how to plan to kind of, deal with this type of, situation is very important. I would say like uh, use that opportunity that is provided in the PhD area to kind of, practice and prepare yourself for this basically similar type of situation in the, industry as well.
I have a
Yeah.
question.
Yeah.
This is Ashkan. I also work with Dr. Maroof. I heard a lot about you. All your
What was your name? Sorry, can you repeat?
Ashkan.
Yeah, I don't hear you well.
Ashkan.
Okay. So my name is Ashkan. Can you hear me now?
Oh, Ashkan. Okay. Yeah, I can hear you.
So I
Nice
heard
to
a
meet you,
lot
Ashkan.
about you. Dr. Maroof told me a lot about you, about your success, the time that you had with him. So I know a little bit about you, and also I read all your papers and everything. So I have one question. Like you covered everything, like how to present yourself in the interview, all the tools, everything. But what's like the most important factor to put on your resume, like to be seen or to get that interview?
Very
And
good
also
question.
how to like tailor the CV for a data science position.
Got it. Yeah, one thing that I feel like is very important for getting the interview is kind of you need to customize your CV based on the position that you are kind of, applying for. So if your position is like related to supply chain, try to have some, I think it's okay to make some changes in your CV in order to make it more aligned with your basically company that you want to kind of apply for. Because end of the day, we have the knowledge, we know how to solve the problem, and we want to just get that basically interview. So try to be a little bit more specific, a little bit more customized when it comes to basically preparing the description of the projects that you have worked on basically in your PhD. So that's one of the things that is important. What others could be?
Like, is there any element on the CV when you see it, you're like, oh my God, this guy is good and I want to interview this guy?
Yeah. I feel like as a PhD student, it's good you have like few good publications. Then I think in this era where kind of AI is evolving very fast, I think if you have like few things like related to the AI, okay, I developed something like, I don't know, some chatbot in order to help the questions related to this project. These are very exciting. So people know that, okay, this person is not kind of specialized in AI, but he's curious and he's using AI in order to basically, do his basically day-to-day job. So I feel like having like some AI related projects in your kind of, uh, in your CV, and also some good publications, that could be really helpful as a PhD student. It's a different story when you are a kind of a master or bachelor, but yeah, that's what comes to my mind now. But
Yeah, thank you. Thank you for the time.
yeah, no problem.
We
Very
have
nice to meet you guys.
Yes, we have one more last question before the end of our session from the chats. And the question was, yeah, thank you, Dr. Aghalari. I'm Piyash, working under Dr. Wang. How does current LLM integration have changed the current industry? Specifically, how do you feel about the shifts and how should we prepare for it for data science related positions?
Very good question. So I feel like the one of the big impacts that LLMs has kind of done to our basically area is, I think it has made the working a little bit easier. So in order to develop like new things, you can kind of do much faster compared to the older times. But I think the interviews are becoming much more complex because of two reasons. One is people are kind of expecting a lot more from the candidates. And the second is basically AI is kind of replacing. We see like there are lots of layoffs like in Walmart, Amazon, everywhere else. So positions, roles are becoming more competitive in my opinion. So LLMs are very good. They are helping, but in other way, they are kind of, hurting as well. So that's how I see the LLMs. But overall, I think the impact is good because using the LLMs, you can do your kind of company work. You can even think of some side hustles. So I have like some friends working at Walmart. They are kind of building some, you know, very sophisticated stock forecasting models. So they are kind of supply chain data scientists, but they are kind of getting involved in finance kind of related things. So yeah, I feel like LLM is gonna change lots of things near future, and I hope it's gonna bring good for all of us.
Thanks for asking your question, and thank you for a wonderful presentation. This recording will be made available. Oh, we have one more question.
Oh, there are questions in the chat. Okay.
Yes. Yeah. Well, yeah. So we have one question from Arvind. Hello, Dr. Aghalari. Thanks for the great session. What is the role of simulation in generating data sets, and how important is simulation for industries? For example, do Walmarts have a digital twin model of their supply chain?
Yeah, it's very good question. So yeah, it has actually. It's kind of hosted in our team. So we have a digital twin which is called Mobius. So what we do is basically there you can kind of come up with your synthetic data and then change the different configuration of the network and see what's the impact on your basically, cost, the delivery speed, and etc. So I feel like simulation may be one of the areas that are kind of it's not drawing people because everyone is kind of interested in LLMs, like, other like machine learning related projects, but there are some very good basically positions related to simulation. There are actually they are hiring like for simulation, like in Walmart in that team. So overall simulation area is important, and I think you guys, if you are interested in that area, I'm sure you can kind of find, good positions.
Fantastic, yes. So thanks, Frank. Once again, thank you again for your presentation and for questions. Any further questions to Dr. Aghalari, please, you can reach out to him by email or LinkedIn. Now, once again, thank you, Dr. Aghalari, for coming. And
Yeah, no problem.
yeah, this video will also be made accessible on YouTube. And Dr. Maroof has one more last thing he wants to say to us.
Thanks for
I
having
just
me.
want to
Hi,
say,
Dr. Maroof.
yeah, I mean, very good to see you.
Yeah, good to see you, Dr. Maroof.
I've been seeing all your outstanding placements one after another. I mean, you are
Oh,
doing
thank you.
tremendous.
I appreciate it, Dr. Maroof. Yeah, I have all this because of your offer, like for my PhD. I did. You gave me lots of good projects, and that helped me to land on this cool kind of work. So I really appreciate it. I'm always grateful for that.
Well, I mean, what you are doing right now is way beyond what we have done. And I see that, the way you have been growing. I mean, I just want to say we are very proud of you, what you have been doing. Just
Appreciate it.
please keep doing the same.
Thanks a lot. Thanks a lot. Yeah, I feel like the same for the ISC department in MSU. I think it's in a very good hand, and we are gonna hear very good news like from ISC department, like in the future under your supervision, Dr. Mar.
Thank you, Amin. I guess we'll close the recording, right? I just want to say a little bit about the personal things.
Yeah. We can close the recording and continue discussion.